1, 2, 3, 1, 2, 3. The question is whether I'm really live or not. I just need to take out something more, so I see. Hello, everyone. I hope you are there, so say hello if you are. And I'm super happy that you are here. So say hello from wherever you are. Just give any kind of feedback that you are hearing me well. I hope so. I configured everything fine. I was not doing webinars for some time, so I hope it will work simply. And let's just proceed. Today we are meeting because we decided that it would be nice to give some kind of in-depth explanation of one of the questions, few of the questions that we have regarding our .NET Memory Management quiz. You have a link on of it in the description, so I hope you have seen it, or maybe you have even tried to solve it. Just to make sure, maybe I will paste it on our internal chat, not internal, sorry, our public chat. That may be probably much better. So you can have it later on, probably not during this time because you will be just distracted by me talking, but still, if you haven't attended this quiz, please really try to do it, because I believe I spent a lot of time preparing it, trying to give a kind of overall evaluation. How do you feel in the area of .NET Memory Management? There are simple questions, there are some intuitive questions, there are some difficult questions. So I hope no one probably will ever get 0 points, so don't be afraid of taking it. And the idea is just, as I said, to have some questions. And to not make this webinar too long, I decided to take 3 my favorite questions, although I like all of them. So I had a pretty difficult time choosing which one I would like to describe as the first, the second. The order in the end is pretty random, but I will try to dedicate 1 hour for describing them. So just be there. And just let me prepare, because I have too many windows. I hope it will be okay like that. Okay, so the quiz is like that. We can start the quiz and then we can start answering. And I have chosen 3 questions pretty at the end. So I won't just, go past all the questions now. I prepared some of them already. And let's start from this one. So we have a question number 26. Whole quiz has 32 questions. And here is the very first one. And it is about LINQ. By the way, as always, just give us a kind of feedback from where you are. And also, maybe before even discussing it, I really wanted to mention that we started as .NETos, and I'm a kind of, let's say, father of this idea to create the community around us, because we really love .NET and learning and teaching knowledge about .NET advanced stuff, performance, and other. So we have created a community on Discord. Some of you maybe are here because of Discord. I hope so, at least. So if you feel interested in topics like that, please feel invited to join us. Here I will just copy paste the link to the Discord invitation. You can jump in now or later on. Every day we have some discussions around that, around .NET in various topics. So just be there. There are no hundreds of thousands of people, so you won't be overwhelmed with the number of messages and overall knowledge. But still, I believe it's pretty nice community. Like, we really try to make it like home, not like public place where everyone is screaming and so on. So let's just proceed. We have this very first question about LINQ. And the question is that every call to something like that, you have a method that is returning enumerable, and it is like an input having a list. And then we are doing super typical thing, like I would say combining where with style with select on some collection is absolutely no magic. Probably are doing that in every application that is using LINQ and database or collections, whatever. So the question is how much. The question is how much is allocated per every call of such a method. You are online. We are talking with each other, let's say. So try to guess. You have 10 seconds while I'm talking. How much bytes is allocated, or even what is allocated in terms of any kind of description during every call of such a method. And then you can share your guess on any channel, like on Discord, on YouTube, on Facebook. I'm seeing all the chats, so I will be seeing your answers. And the question is now why I like this question. This is because it shows something about LINQ itself, which I believe in the end. But because this is super powerful thing that allows us to write very convenient, fast, maybe fast or not, but fast to write code that transforms things and so on. So we have some guesses like B, C, B, and D. Let's, before answering, measure that, because we can do that. And for measuring things like that, probably I would like to incorporate benchmark.net or any other tool that will allows me to measure performance and allocations. So for the purpose of this exercise, I will use benchmark.net. If you haven't used it, that's something that is for measuring performance in .NET. It is that tool. No one thinks about using anything else if you would like to measure kind of micro benchmarking. So you have a single method and then you measure how it behaves in terms of performance, but also you can measure how it behaves in terms of memory. So how much do you allocate? So here we have this method, exactly exactly the one from the question, although here we have generics, but it doesn't matter. So it is just taking some input and you combining where with select to have a enumerable of int result. And that's something that we would like to measure. So that's the approach in benchmark.net. It's very similar to approach of unit testing, I would say. So you have some code that you would like to measure. Exactly like with unit testing, it is good to have kind of good design to be able to extract what do you want to measure. And in this case, I'm just using some synthetic code. So that's something very easy for me, but typically that would come from your application. Maybe we will just include your core library from your application and having some method that you would like to measure. But here we are using this because we are interested in some simple experiment. Then the method that we would like to measure, we need to wrap it around the benchmark itself. So benchmark.net, maybe I will link it here in chat because maybe not everyone may be aware of this awesome tool. So I'm just pasting the link on chat to benchmark.net tool itself. And so then it is just a NuGet package. So you include it in your project, and then out of the sudden, you have a project. Typically, it will be console application that is able to benchmark things. How you can do that? You need to create a class that needs to be public. Then you create methods that will be benchmarked, and you need to attribute them with the help of benchmark attribute. And that's almost all. So it doesn't sound like a magic or something that is hard. But as always, when doing such kind of benchmarks, you need to be really careful whether you really design what you would like to benchmark, because if, for example, would omit something like that, our code would become let's say, benchmarking something that is not consuming this collection. If you remember how enumerable is working in .NET, then it simply means that this is a method returning enumerable, but no one is iterating over this enumerable. So in the end, we don't use this enumerable, so we won't be able to measure anything significant. Benchmark.NET is wise enough that if you would like to benchmark it, it will even complain, saying you cannot measure it because you are measuring enumerable which is not consumed. For doing such a things, we have an extension method in benchmark.NET just to consume it. So we are, let's say, artificially consuming this method, which returns enumerable to trigger really using it. And then some setup, like in unit testing, we need some initial setup. We have some initial setup. Here I'm just creating this input that will be processed like 1000 random numbers. This will be executed only once before real benchmark, so no problem here. You can write any code, like it may be slow, not optimized. It will not influence the results of the benchmark itself. So I don't care whether I'm using here LINQ or something which is allocating a lot or not, because this will be executed only once. In the end, I will be benchmarking this only once. And sorry, not only once. In the end, I will be executing this as a benchmark multiple times, as we will see. Additional thing that I have added here is just to have memory diagnoser attribute, because this is something that will additionally allows me how much data, how much bytes is allocated during execution of such a method. Without it, I will be just measuring the time of execution of such a method, but with the help of it, I can additionally measure allocations. And then a simple single method to execute to trigger benchmarks, saying I want to run benchmarks, all benchmarks from this particular class. So in this 24 lines of code, we have just prepared benchmark that will benchmark how much we allocate during this method. And now we can compile it, and I hope it will work, and we can start executing benchmarks. If you have ever executed benchmark.NET benchmarks, then you will see that they are executed millions of times just to make sure that you have any reliable results. So it is not like stopwatch, which is before and after executing a single call, but it is just calculating many times. First of all, what is the number of good calls in a single batch? Then it is just doing some warm-up, then some calculating the overhead, doing the warm-up before real workload, then testing the real benchmark. And as we see here, those are hundreds of thousands of calls just to make sure those measurements make sense. In the end, we have this table, which is so often visible when we are reading about performance, because everyone is using benchmark.NET to show any changes in API, improvements of performance of particular methods, and so on. So here we have it exactly like that. The core of this result is just this table. And we see, okay, there is information that every method call takes around 6 microseconds, so that's not a lot. But we also see this information that every call of this method takes 122 bytes, which is, I would say, more than zero that one could expect when looking at such code, because then it means that our very simple method that is just processing an input and doing some filtering and then executing anything that will result that give a result that is just the square of the input. Now, out of a sudden, this single line, every time when we execute this method, allocates those 122 bytes. And now the question is, what is allocated? Because we see that something is allocated. So, okay, that may be not a big number when we do that once, but if you have a code that is called thousands or millions of times per second, maybe even, then you will create megabytes of garbage just because of those lines. So it seems okay, that may be a problem or not, and that's always the approach when I'm teaching about performance in my course about .NET Memory Management. I'm always saying, don't bother if it is not a problem. So in a whole 14 weeks of the training, for example, I'm trying to show you the tools to discover paths when there may be a problem like that, and only then you should start to optimize it, not to start optimize everywhere and select in your code, because it doesn't make sense. Maybe it is code so not so significant amount of times, it is not on hot path, and you simply don't care, and that's totally valid question. We shouldn't be bothered about those 120, 152 bytes if it is not on our hot path. On the other hand, we could say, okay, but I mean, you will read even in .NET that documentation of .NET that they do not invite you to use LINQ on hot paths. So there is a kind of overall generic advice from their side, because while LINQ allows you to really efficiently write code, it doesn't have to be efficient in the end. And that's one of the reasons. Okay, but how we can now discover what's allocated? Because probably now we would like to know. And here we can use various approaches. Any approach for profiling will be just fine, because there are various APIs exposed by .NET itself, profilers that can be plugged in to track what is allocated. You can use ETW with the help of Purview or any commercial profilers, just to make any significant measurement that will allow you to discover what's there. Today, I would like to present one of the approaches, which will be about using JetBrains.memory, not because I'm in any way paid for promoting JetBrains.memory, but personally, I perceive it as a really nice tool that can be used for such purpose. And what is really nice about JetBrains.memory, if you will see in general, it's as any other profiler, it allows us to attach to running application and profile it, or start the application and profile it. That's the only two possibilities that are both available in this tool. But what is really nice here, if you will look, there is information how you would like to control profiling. And there is a manually control, which simply means you will start it when the application starts, for example. There is a button when you can start or stop profiling the session, but there is also option to use API. And then it simply means API will be controlling what and where do you profile. And this is something that I would like to present you now, how we can utilize this feature to measure simply what is really allocated in this particular method. How we can do that? First of all, we need to have a code that we will be profiling. So to not waste your time when I'm typing code and making typos and so on, I have prepared code for doing that. So here we have a method that will be simply calling. I'm utilizing, because I'm lazy, I'm utilizing exactly the same class. And what we would like to have is just to call this particular method. So I'm doing that. In my code, I have a dedicated method when I'm just newing up the same class, calling the setup, and then calling processing LINQ, so the method that I would like to measure. But there is also this magic, which is just memory profiler API, the one that is mentioned in the tool itself. because there is a package that we can add to our an application, .NET application, which is called JetBrains Profiler API, a regular NuGet package that you can add. And then simply you have access to those methods that will talk with the instance of running .NET memory, JetBrains.NET memory running somewhere on the same machine. And it has, as you see, really, sorry, it has, as you see, really simple API. So you can start collecting allocations. And then, for example, you can trigger getting a snapshot. That will be something that you can we can analyze what happened. And in the end, when just having those two calls between our method, we will be having this very isolated point, very isolated method that we will be tracing, profiling, including allocations. That's something really, really nice that we can have. And now we would like to obviously to trigger such a code to have some results. So we need to sorry, not this one, but yes, I want to call this one with the flag true. And I could do like that. So we would have now an application that is simply, as you even see, it is .NET 6 application with top-level statements. It is just starting our method with the flag true, so we will be doing this measurement. However, when doing any kind of benchmarks, we should be always careful because we can very easily start to measure something that is not correct, I would say. And here it is the same case because first of all, we are calling this method only once. So we are exposing ourselves now to the possibility of any warm-up, like this method needs to be JITed, and that may provide some garbage that we would like not to measure because we are not interested in the very first call of it, but any other usual calls of it. So just to make sure I'm just measuring what I would like to have, I'm doing this very first dummy call to warm up, to JIT everything, to have everything in place. And only then I'm doing the second call. I could even call those methods probably multiple times, but I believe once will be enough. And then I'm just doing this real benchmarking profiling call that will collect the allocations. Yet another one thing is I want to measure this method. And currently, I'm not sure what will happen with this method in terms of inlining. If you have ever, let's say, read anything about JIT or performance in .NET, then you may know that this method may be inlined. So because it is a short method, JIT, when producing code, may decide, okay, let's just embed body of this method inside this method instead of calling it. That would be good maybe from the perspective of, let's say, performance, but I really want to have it dedicated call. It doesn't influence the performance, but I will be just having better, let's say, look at the allocations, because if I will have inlining, then all allocations from this method will be like inside this method and all will mangle all together. I really want to have allocations measured only from this single call. So I have just added the method implementation attribute, the one which is just defined in system.runtime compile services, to no inline this method, just to make clear, distinct call that will be really measured. And I believe that's all, if I haven't omit anything important. So let's just compile it. And now we will execute this method and this code. Yes, and I would say it is as easy as adding new process to run. Then we simply configure what we would like to execute. I have here a path already configured to what I would like to execute. And one more thing about measuring. Always we should be aware what we are doing. If you have ever read about .NET JIT or performance, you may be aware of tired JIT, which simply means JIT now works on various levels. By default, when you first execute your method, and the very first 20 calls of a method, as far as I remember, the threshold will be jitted in something which is not optimized because we believe it's not worth to optimize something that is not called often. And only after this threshold number of times, let's suppose it is 20, it will be rejitted to the very optimized regular version. But when doing such a benchmarking like that, I don't want measure something that is not optimized. I really want to measure the final version of it, like the one that will be executed if I will be really thinking about performance. So I'm just disabling also with the help of this environment variable, this possibility that the tired JIT will be used. It will be simply disabled, and it will be everything here will be now compiled into this normal, really optimizing version of JIT. So I hope it is configured. We should start now execution of it, and it will stop very shortly, obviously, because it is super short application, like it was printing something to the console, and that's all. But because of the API, as we have seen, the magic has happened in the background. So the snapshot has been created, and allocations were started to be profiled before. So we have here the snapshot. Obviously, we were not able to click so fast during a regular application work, but because of the API, it is just working correctly. And we have the snapshot. And inside the snapshot, we have a memory allocations option when we can look what was really allocated during this time between we have started allocation tracking and before snapshot. And here we have information what was allocated. We see pretty a lot of things, as you see, because it may also include a lot of other, let's say, allocations that has happened because of other code before and after. But we can see in call tree, we can just go to the call tree and find our method, which is because it is the top level statement, it has this pretty strange name like main test processing. But in the end, there is processing LINQ, the one that we have just, we were going to profile. And there, at least it seems it is working correctly because we see exactly the same number of bytes allocated as LINQ was stating. I hope you see this inside the stream. I'm not sure you have if I have a zoom, maybe I will be able to zoom something here. Okay, but that was not a good, no. So we have a process LINQ. It is just 125 we have mentioned, and now we have information exactly what and where was allocated. So we see that select has allocated this number of bytes and where this number of bytes. And if we will extend it, we will see that it is the enumerable where select list iterator and enumerable where list iterator, which simply means two iterators were created just because we have started to use those methods from LINQ. So where and select, which is how the LINQ is implemented. So every time when you use where method to create something that you can iterate over, there is a dedicated instance of where list, in this case list iterator. Later on, when you start to combine it with select, then simply there is a new iterator created which combines them both and it is where select iterator in this case list, because we are iterating over a list. So that's pretty nice. Like with the help of this tool, very fastly, we were able to see what we have allocated during this method. We have even confirmation that it is the same value like it was in case of benchmark.net. So that's super nice. And why I like this question? Because simply LINQ is so popular. And while it doesn't have to be a problem in your application, it is really nice to have this in mind, that if you're really working on something that is at least somehow close to be a hot path, you are simply allocating things. And with the help of such tools like that, you can measure, you can improve, you can validate whether you have really improved things or not. That's really nice. Obviously, you can ask me also whether, okay, so how we can use, what we could use else instead of using LINQ. And obviously now your mileage might vary. Like typically, if you'd like to implement something that really returns enumerable because you really want to, you can, for example, use the yield returning method. If you have ever read about it, there is this option in C# which is allowing to create an enumerator with the help of the yield keyword. This is a magic of C# support of it, and it is still returning enumerable, but without LINQ. It is simply like almost like plain old for each, but with this powerful possibility to return enumerable successive elements. And the question is whether it allocates less or more. It still allocates because it needs to create an underlying state machine that will be tracking which next element should be returned and so on. So it is not as good as not allocating everything. But I would say it should be less. So let's just make a very fast test of it. I will just use the same pattern here, but instead of calling this, I will be just calling yield, and it should work. So I will just fall back to using benchmark. By the way, if you have any questions, do not hesitate to ask, because it is absolutely interactive webinar. So feel free to have any questions here on chat or on Discord, and here on YouTube, Facebook, or Discord. So then we have process LINQ, process yield with exactly the same API, because both return enumerable of int. And that's all. I've just added another public method with this attribute. So now after compiling, it should start to execute both benchmarks one after another. So it will take some time just to make those measurements. And in the meantime, I can check chats whether we have some questions or not. So does JetBrains Profiler API require a license? I don't think so. I rather not. I mean, it probably the only need you have is just to have JetBrains simply, and the API itself, and this nugget is free, so no. And the second question, this record will be available definitely on our channel, so you can always return to it. Absolutely. Okay, and here we see the results. So we see that process yield indeed is not only faster, maybe that's not a tremendous difference, but still it is, mostly probably because it is also less allocating. More than 2 times less allocations is produced because we have just returned to plain old yield instead of using simply the whole LINQ machinery. And that now we could repeat the same exercise to see what is allocated there, but the final conclusion would be that it is the state machine that is created for real returning magic that is allocated there, which takes 64 bytes, which is still some amount of memory, but at least more small. Still, however, I would say maybe you don't need a method that really returns IEnumerable. Maybe you can just use for or for each and do something with those elements instead of returning it. Or maybe this IEnumerable is always immediately instantiated to list, so you can simply create the result here and do not create any additional allocations because of any state machine or anything else. So that would be something like solution to this problem, how not to use LINQ. Okay, question, why do we use no inlining? In general, I was not using no inlining during benchmarking, but because of profiling later on under .memory to make sure that I'm measuring this method and not everything else, in benchmarks we can get rid of it if doesn't matter, I would say. So that was the goal. Okay, so that will be the very first question, and if you will have any more, I'm going to create private, not recorded, short, let's say live meeting on Discord after that. So if you have any more questions, please be invited to be also on the Discord channel, where we will have an opportunity to discuss it a little bit more. And then the very last question until I will move forward. Is there any way to move? Is there any way to avoid more allocations for this case at all? I would say only if you decide not to return IEnumerable. So unfortunately, if you'd like to, you need something that will magically produce element by element. If you would like to, but typically it may be that this is simply used somewhere in code, like public void use stuff, and then it may be that 99% of code looks like results is processing yield to list or something like that. So the way to avoiding this is, I would say, in such case, the way of avoiding allocation is just to do such a plain old approach, like just create list of integers here, which that will be created inside the list, provide even if you know the expected capacity of the result, and then just add them here, and you will avoid any allocations that will result from processing the list itself. That, yeah, like you don't have anything additional here, simply you are producing the list itself. So that would be the solution, I would say. Plain old and sad way of iterating over collections. Okay, let's move forward because I would like to have a chance to answer other things. I see some questions, but maybe this is worth answering. So does using no inlining mean that in some cases this simply I don't think so. Like, this will always create those two iterators, no matter whether it is inside this method or maybe inlined in something bigger. That's simply what the LINQ is doing. My approach was simply just to make sure I'm measuring exactly this method. That's why I have forced no inlining. Okay, let's proceed. The next question is about string interning, because I like I mean, maybe I don't like, but I see some confusion about the fact what the string interning is. And now a few seconds for you to think what are the correct results. And I have some slides about string interning. So just to make sure I will fit inside 1 hour, now I would like to have shortened maybe an answer around the string interning. So what is really string interning? It deduplicates any string generated dynamically in your code, or maybe it deduplicates a string literals, so that's recognized as the same during compilation time, or maybe it uses a dedicated part of the managed heap for intern strings, or maybe it is not thread safe. So now a second for you, or 10 seconds, let's say, for you to try to answer, and I will just drink a little. Good tea is good thing. Okay, so what is the answer? Any guesses? I will check webinar and Discord. No guesses. Yes. ABC, very first guess. ABC, so it deduplicated strings generated dynamically during compilation time and uses special dedicated part of the managed heap. Another is that it is only B, and another is that it is A, that it is planned, and B, that it is yes, and C, perhaps, I'm not sure. Okay, so this is exactly around those confusion points that we can met, because I was even seeing presentations stating that it is A, for example, which is not the case. Or I was seeing presentation, probably even other ones, that was stating that it is C because it is using something like the intern pool or so. So just a short story about string interning. Using some slides from the course because I'm lazy. So there is a pool of cached strings in general, which is called intern pool. And this is exactly the string interning the whole machine is to reduce memory footprint, because for sure typical applications have some duplicated strings. But out of the box, it is working only for string literals. So not only having the same value, but also of, let's say, value that is known at compilation time. Okay, we can manually use it here and there, but it is definitely not applied to every string we can dynamically create with the help of string append, string concatenation, or string format, or anything else. Why? Because it would be just probably not worth overhead, but because checking against string intern pool is not trivial. Like, imagine you have millions of strings in your app, they are all inside this pool, and you have just created a new string, and now you need to detect whether you have it already or not. So you need to somehow scan this and detect, and that is not trivial to implement. There are other implementations I will mention, but this is not like it is working. Currently, it is only for string literals, so everything that is just in quotes that can be detected at the compilation time. So coming back to very popular hello world case, this is a string literal. It is known at compilation time. When you compile such a thing, the compiler is producing assembly file, obviously, the DLL file that contains everything. It also contains a stream of such user strings, as it is called. So if you will binary look at this file that is compiled, it will contain this hello world simply as set of Unicode characters inside the assembly, physically inside this DLL. They are all strings that were detected during compilation as having value, and they are just there. And what is string? Every such a stream that is there has some metadata token. So let's say some identifier, and there is information in the ECMA standard that is defining .NET in overall, that if you have as instructions that are using such metadata tokens, but they are having the same value, as they are saying the same sequence of characters, they should return the same string object. So the idea is exactly, maybe it is said here in a little bit more verbose or academic words, but the idea in general is, if you have multiple the same strings in the compilation unit, they should be used as a single string in memory. And this is in the end using this string intern pool, as how it is called. Can I move this, because I cannot move the win. Maybe I will use this view, then I don't hide anything. Okay, so this string literal map, it is also called like that. It can be also seen like a string intern pool. What is happening when you are using such hello world, like here we are just trying to print hello world, it is trying to load this string with this ID, which is called metadata token, but in the end a new string is simply allocated in such case. If simply it is, and this is happening at the compilation time, at the JIT time, sorry. So if the JIT will see, okay, there is a metadata token that we'll try to read, and there is no such a thing inside the already used literal map, string literal map, we will just allocate a new string and just copy this data from this binary file that we have seen previously, and that's all. And then the only thing that is different is that we will be just keeping information about this string in this string intern pool. So later on we will be able to use it again when again the JIT will detect that we try to read something which is the same. So that answers another question. There is no dedicated managed part of the heap or anything else for such a strings. They are just regular strings that will be probably created in the small object heap, or if they are really big, on large object heap, and every such string literal will be just allocated there, and the instance of it will be living like any other string instance, so probably it will be promoted to generation 2 in the end, and so on and so on. There is some internal implementation of it, so how, for example, let's say, who is keeping alive such strings, there is a array that keeps them alive, and so on and so on. But in the end, from the perspective of the GC, they are really regular strings treated as any other. They will be compacted, moved around the GC heap if the compaction will occur, and so on and so on. So that's why it is so nice. I mean, maybe not so nice, but surprising. There is no dedicated part of the managed heap for string literals. The only difference is that they are somehow tracked by the internal data structure to know, and this is efficiently. So there are some hashes how to find fastly string with literal with the same value. But in the end, it will be just information. Okay, if you want to now use the string with the given value, there is an entry in this array that points to this string, and that's all. That's why in the end, if you have ever seen assembly, or maybe not, don't be scared. This is in the end what is produced when we are executing those two simple lines. JIT has produced simply a specific address inside this array dereferences it, and it gets reference of a string. And then it calls console write line. But that's super low level thing, I would say. So we don't have to cover it probably now. That comes, it makes better sense maybe in the whole course when I'm just putting all the context of it, but doesn't matter. It is, let's say, kind of short answer that it is deduplicating string literals, and that's all. There is no dedicated part of the managed heap for that. There is no, now it is not used for the dynamically generated strings. It is thread safe, and that's all. Why I'm looking it as a kind, why I've chosen this as a favorite question, because of this confusion. I don't like confusions, and I believe it is worth to understand this mechanism, because in the end it is not so useful if someone would think that the duplication of strings happens because of that. And now time for questions. Which tools do you use to show binary view of the DLL and GTED code? So there are two tools. First of all, for decompiling the DLL itself, I'm using dnspy tool, so I'm inviting you to use it. Oh, interesting. Maybe I will just paste the code, the address to the GitHub. It is open source tool that you can use for decompiling, debugging, not your assemblies. Really powerful thing. It will also allow you to see things like that, the internal structure of those files, even showing the binary data itself. For decompiling, the beloved sharplab.io. So if you would like to ever play with decompiling anything in .NET, this is another tool that is no-brainer. Everyone is almost using it. So you have any code that you can decompile to IL, or you can even decompile to the assembly code that has been generated when using this particular method. So if you will use it, something like that, it will just show you how the code is working. You can play interactively, as you see. So probably I will make a webinar about that, or maybe webinar about the IL input, because we can also play with not only C# input, but also, and something as always in live demos, something is not working. You can also input IL directly to play a little bit with the IL. A lot of potential for possible webinars. I saw another question. If we get large now, no, there was another one before this one. What happens when using string intern string? Yes, so this is the API to manually control things and manually control intern pool. So I had some example of it here, I believe. Let's just give me a second. In general, string intern pool has this logic that it returns a reference to a string if it is in interpool, or it is adding this string to an intern pool if it was not there. So it is something that you kind of manual deduplication that you could use. And there are some, let's say, use cases of it that you can meet in not so, let's say, typical paths of your code, when, for example, you see a lot of duplicated strings, and you want to, you know that you are getting a lot of strings that have similar value, like, for example, HTTP verb or name of your customers that are limited, let's say, in what values you can get. So you could use interning for replacing the instance that you have just received from network with the interned version of it. So the one that you have just received will be no longer needed. It will be garbage collected, and instead you will start to use this intern version, and then it is a little bit better for the GC pressure, because those short living duplicated strings will go off, will be this garbage collected, and you are staying with this only in intern pool, if I have explained that clearly enough. If I get a large number of same strings, yes, that's that's something that probably I tried to explain in the last few minutes. So yes, that's the case. If you have something like that, you can think about it. The only caveat here is that string intern pool doesn't allow you to get rid of strings from there. So it is like ever growing pool, and typical cache or anything like that likes to have any kind of trimming logic. So after some time, maybe you would like to get rid of those strings that are no used or anything like that. It's not supported in .NET in Interpool currently. That's why I would say that makes sense sometimes, but you should be careful, because it may be in the end worse, because your intern pool will gather all values that are multiplicated, let's say, without possibility to get rid of those strings from the pool. So always measure. No one will say it is good without measuring. And in the end, I see something that is just touching the topic I would like to cover. So I heard once that in Java word, we need to use just plain dictionary strings that duplicate strings for a specific case. So here the typical approach is or using string intern, or writing your own string intern pool that supports trimming. There is no standard solution. As far as I remember, you need to write something on your own, unfortunately. However, also, I don't remember if I have it on slides, so probably I will just not wait. Oh, I have. Okay. So there is an ongoing work in .NET to include dynamic strings deduplication, something that Java also have in one of the runtimes. I don't remember even whether it is enabled by default. But imagine that you have background worker in your runtime that doesn't do that during the string allocation, but in general it works, and periodically it checks whether you have if you have duplicated strings or not, and replace them somehow magically with the intern version. This is the generic string deduplication, which is having some initial discussions, and I can link them even, because .NET team is thinking about that. So maybe we'll have something like that in future, or you may reuse string table, the thing that is for example, Roslyn, the C# compiler team, has something like that. So you can try to think about using something similar instead of writing from scratch, but still it will be a custom solution. Okay, let's just move to the very last question. I have 1 minute, so that will be pretty hard, but let's just give a second at least. I by design left this as the last question, because it is the probably least surprising one. So I will just go to the question I wanted, this one. Dispose method. So the very last minute, maybe 5 minutes, just give me 5 more minutes. Dispose method. This is a very similar thing to the interning in terms, why I chosen it, because it again produces some consternation and confusion that I don't like in this case, because I'm even sometimes, let's say, I can't recall the word, annoyed, because it is so easy concept, but still I'm constantly seeing wrong understanding of this topic, for example, on Stack Overflow. So here, what is dispose method? And just, yes, as I even see on the chat, it is, oh, sorry, that's the magic of Typeform. It is just a contract to say this type instance require explicit cleanup, period. It has nothing to do with the GC. It doesn't dispose memory after an object. It doesn't mark it as unreachable. It doesn't reclaim memory of this object. It doesn't dispose it in any way. It doesn't do anything, and GC is even not totally aware of the fact whether an object has dispose method or not. This is just a contract that has been created because in general, when you have types that may hold some resources, typically some unmanaged resources, then you would like to have some explicit cleanup, like saying, if you are done with using this class instance, just call this method to clean up things, to release resources. But then one would call it close, another will call it cleanup or collect or tear down or reset. So instead of having this confusion, there is this common, well-known standard. It is disposable object, and if it is implementing it, it simply means it is not because someone have such a idea, but it is because it should be disposed. So if it is disposable, dispose should be called when we are done with it, and period. That's the whole topic about disposable objects, I would say. No GC relation doesn't trigger GC, doesn't trigger collecting it, nothing like that. I would agree that this is sometimes connected with disposable pattern, but that's another thing, and still it is nothing about the GC itself. It is just how it is cooperating with finalization and finalizers in general. But because it is a common contract, the another powerful possibility is that C# can have using statement, well known, that is consuming it, and we are using all it because of that. So using statement is just an additional helper that allows us to have control over that. If you have disposable object, instead of remembering to call dispose in all possible paths when this object is going out of scope, you can use using in C#8 even with this simpler syntax, when it will be just really called dispose injected. Dispose call will be injected really when this local variable goes out of scope. And that's all. That's, I would say, all. The only thing is that we have disposable pattern. And just a very last minute I would dedicate to that. Yes, in these terms, it's a little just touching the topic of memory management, because typically we use disposable to control also finalization, or maybe opposite, I would say. If you have disposable object, it means that someone should call dispose, because it is require explicit cleanup. But we don't trust programmers. We don't trust the users of our library. So we are creating a safety net in form of the finalizer. And this finalizer only responsibility is to call dispose on its own if someone has forgotten to do that. And that's why it is sometimes connected with finalization, but that's all. Still, it doesn't touch the memory management in any way. And then only in the dispose, if smart developer is using our type and it has called the dispose, we are just let's say, canceling finalization because someone has already disposed our type. So we are not forced to use the safety net. We don't need finalizer because disposable work has been already done, so don't bother now. We are just canceling any future finalization, so this method won't be called. Apparently Chris is not watching us, but Chris is a person known for not liking disposable pattern in terms of how it has been named. For example, this dispose common method with this disposing argument. Yes, I agree, this is a little bit of confusion here, but in the end, just 3 minutes and you will understand simply what's happening here. So probably we could name it a little better, but this is only for as a safety net if you have a finalization. That's the goal. If you have a disposable type, finalizer may be your additional safety net, period. It doesn't reclaim memory in any way. And that's, I believe, nice moment, I would say, to stop answering. I have covered those 3 questions. We have 32, so 29 still to be described by me. If you feel interested, you can still take the quiz. As a result, as the very last part and the question inside the quiz, you can provide your email, and then you will start a sequence that will provide you detailed answers for every question week by week, which is just something like, I have it somewhere here or not, I closed it. It will be in general 4 answers per week, so you'll have a nice pace of learning all this stuff with some explanations about all the questions. I hope deep enough to understand those correct questions. Okay, I will just answer one more question that I have seen from Jose, and that's also a chance for you to ask me any more questions if you have any. And returning to this, ownership and borrowing in Rust is awesome. That's my answer. That's super nice capability of the Rust management, Rust language, how it manages memory. I like it a lot. It's a pity that .NET Runtime won't be probably able to do anything like that in the nearest future, but still, if you feel interested in something much modern, maybe not much modern, but a new approach to the Rust memory management, read about Rust ownership and borrowing. Or if you feel it is interesting, just ping me somewhere to motivate me to create a webinar about that, because why not? I can give you short description of Rust memory management and how it compares to .NET. So that's all. I'm just going to Discord now to have any chance of having short chit chat with you there without recording stuff. This webinar was recorded, so will be available here on YouTube immediately after it ends. So the same link will be for the recording as it was in all announcements. And I believe that's all. Thank you very much. See you in one of the next webinars. If you felt it is interesting, you can also suggest what I could talk about in next webinars. What is your interest area in performance, or maybe in general in .NET. Bye. Have a nice day, or evening, or morning, wherever you are. See you next time. And broadcast. Thank you for watching.